Okay, so now we're going to look at number 6 and number 7. Looks like we have a 20-meter building. So we have this 20-meter building, which we're going to throw, and we're going to be shooting a straight up object, straight up a ball at 15 meters per second. So our initial velocity, where this red mark is straight up at 15 meters per second. It's going to go up, turn around, come back, and then it's going to go right next to us, straight up and then straight down, like we leaned over the edge of the building to throw it up. So then as it came back next to us, then it went all the way down and hit the ground 20 meters down below. Okay? So first question, on the way down, just misses the building, continues on until it hits the ground. How long was it in the air? How fast was it going before it hit the ground? So these are nice, easy questions. And we go ahead and we have the initial location be the top of the building, the final location be the bottom of the building. So we know VI. VI is plus 15 meters per second. We don't know VF down here at the bottom. We know the acceleration due to gravity. We're going to use a negative 10. Notice the acceleration is a negative 10 on the way up. The acceleration is still negative. The acceleration is going down even as the velocity is going up. At the top, when it stops, the velocity will be 0, but the acceleration is still down, negative 10. And then on the way back down, the acceleration is negative 10 all the way back down. We don't know the time. Delta x is negative 20. That's because this is displacement. It's not the total distance up and down. It's just where was it at the start, and then where is it at the end. And at the end, it's 20 meters lower than it was at the start. So we have a negative 20 meters for our displacement. So we have 3 of the 5. So these 2 that we don't know, we can go solve. Our first thing we'll use is VF squared equals VI squared plus 2AD, or delta x, from our equations. That enables us to get the VF. Notice that when you take the square root, that you'll take the square root of 625, and when you do that, you'll get 25 on the calculator. But you need to recognize that when you take a square root, it's either plus or negative. And since it's going down at the end, we know that the VF here has to be negative 25. Okay? Now that we have VF, we can go to VF equals VI plus AT and plug and chug and solve for t. That negative becomes very important here, because the negative 25 minus 15 gives us a negative 40, divided by the negative 10 is going to give us our 4 seconds for the total time up and down. Okay? So that's number 7. By the way, I should point out on 7, we never figured out how high the ball went because it wasn't asked for. And if we did, we would have to change, say, our final location here and instead put it at the top, in which case VF would be 0. We'd do a whole nother set of problems like these, do a whole nother set, and then we could figure out how high it goes. But it wasn't asked for, so we're not going to bother to do that. Number 7, on the other hand, is exactly the same question, it seems like. It's 20 meters high. We're throwing it at 15 meters per second. The difference is that this initial velocity is down. And down means that we're going to put a negative on our initial velocity right here. So that negative initial velocity, we go through the same steps, but you'll notice that it changes our answers, not in VF. Here you still get 625, and when you take the square root of 625, you recognize that you need that negative 25, so that's wonderful. Everything looks the same except, excuse me, when we go to solve here, we need to put a negative 15. So we get a very different time, 1.0 seconds. Notice, much faster because we're throwing it straight down. The ball didn't go up and then down. It just went straight down. So a lot of things are the same, but the time is much less on number 7. That's number 6 and 7.